Okay, so now let's continue with chapter 4 in statics, some laws on moment. Now, as we know that the moment in vector form using the cross product should be equal to R cross F. Remember, it is R cross F and not F cross R, because F cross R will give me the same answer with opposite sign. And what is R? R is basically from the point of rotation to any point that belongs to F. Now here, I want to prove that MO could be found also using another method that obeys to the distributive rule. So if I know that F in vector form is equal to F1 plus F2, or in other words, F is the resultant of two forces, like this case here. So here you can see that F is the resultant of two forces, F1 and F2, which means F in vector form is equal to F1 plus F2. So F in vector form is equal to F1 plus F2, since this is what? This is the resultant of these two forces. Okay, so basically guys, R here and F are vectors, okay? So it is equal to R cross F1 plus F2, of course, in vector form. Now I know that the cross product is a distributive law, which means I can do the cross for R and F1 plus the cross for R and F2. So this is R cross F1 plus R cross F2. Now here you can say that I already know this rule because I know that M resultant is equal to what? It is equal to the sum of all the moments in vector form. And I know that each moment is equal to what? To the sum of R cross F I. So if I only have two forces, the resultant moment will be, of course, R cross F1 plus R cross F2. So I already know that the resultant moment is equal to the sum of the moments where each moment is equal to R cross Fi. However, for this slide, I need to apply this rule for the problems of 2D. How? Let's see how. Basically, if I have a 2D case, in 2D, I know that any force F in vector form is equal to Fx I plus Fyj, because in fact, if I am in 2D case, then F has two components, one in X and the second one in Y, and they are both in XY plane. Which means if I need to find M of this force F, it is R cross F. Now let's replace R by the position vector from O to F. So if this is F basically, then R should be from O to a point on F. So if I take the point of the start of the vector F, then R will be what? R will be also xi plus yj. So this is R. R has two coordinates, x and y, which means r vector is equal to xi plus yj, and here I'm only substituting r by this equation, and I will substitute f also by its equation. And then I know that the cross product is distributive. So what I will do now is to do the cross product of xi for fxi and fyj, and to do the cross product of f of y with fxi and fyj. So basically it is x times fx I cross I plus x times fy I cross j plus y times fx j cross I plus y cross fy times fy j cross j. Now I really know that the cross product of two parallel vectors is equal to 0, which means I cross I is equal to 0. So what I will do now is to remove all the term that where the cross product is equal to 0. So this is basically 0, and this is basically 0. So I will end up with the following: x times fy I cross j plus y times fy j cross I. Now if I go back to the following methods, I know that I cross j is equal to k. So I cross j is equal to k, which is very evident. I cross j is equal to k. And j cross I, so this is j cross I in the opposite direction, is equal to minus k. Which means basically that the answer here is x is fy x k, or k in vector form, minus f xy k. Or in other words, it is equal to f y times x minus f x times y k. So this is basically the moment of a force where I know the components in x and y plane. First of all, I know that f is equal to fxi plus fyj, but I also know that r, which is the position of f, is equal to xi plus yj, so I can do the distributive law, and the answer is basically could be applied for any 2D case. The moment is equal to fyx minus fxy, and the direction is in k. Now what if I need to do the same using another method? Basically, if I go to this slide, you can see that here f is divided into two components, fx and fy. And then this f occurs at a position x, y. Now, I know that the moment of the force F is also equal to the moment of the force Fx and the moment of the force Fy. And now what I will do is to apply the rule of the moment in 2D case. So I know that the moment in 2D case is equal to F times the distance that is perpendicular, that is the perpendicular distance from the point of rotation to my force F, and that the direction of the moment should follow the right-hand rule. So I will assume that my positive direction is the counterclockwise direction, which means it is plus k to compare my answer to this answer here. And then let's do it. What is the moment of Fx? Basically, the moment of Fx is Fx times the perpendicular distance to O, which is y. So basically, it is Fxy. Now, what about the direction? If I apply the right-hand rule, Fx is doing a clockwise rotation, so it is negative. So it is minus Fxy. What about Fy? Fy is doing a positive direction, and the perpendicular distance from Fy to O is x, which means the result of the moment is Fyx minus Fxy, which is the same as this answer in the positive k. So now, guys, you have a lot of methods to apply in order to find the moment. You should choose one of them based on the given. So basically, if I have a 3D case and I can find f in vector form, I will apply the cross product. And remember, in the cross product, you don't have to worry about the sign. Now, if I am in 2D case and I know the distance, or I can find the perpendicular distance, so it is easier to find at the moment as f times d, and then to apply the right-hand rule in order to find the direction. Now, if I am in 2D case and I have the components of f as fx and fy, I can directly apply this rule in order to find the moment. So it's up to you to choose the easiest method that will not consume a lot of time. Thank you.